Hello and welcome to a four-part presentation on factoring polynomials. Now, I generally have about 6 weeks to teach this in Algebra 1. You guys have 2, and you're going to have to work hard to teach yourselves, come to office hours, and come to class. The objectives here are to apply the various methods of factoring to a polynomial and to explain how the various factoring methods apply to different polynomials. There's a lot of vocab that we got to go over before we can even begin talking about our factoring of polynomials. The first thing is factor. What is a factor? A factor divides a number completely without leaving any remainder. A polynomial is an algebraic expression that represents a number that includes multiple terms of varying degree. So what do I mean by degree? I mean that the degree of the polynomial x squared plus 2x plus 3 is 2 because it's the highest exponent in that term. So the degree of the term is the exponent of that term. So a monomial is just a term. Okay, mono means one. So one term. Binomial means two terms. And a trinomial is 3 terms. These are the three. We're going to face 4 kinds of polynomials to factor. And they're going, well, 3 really. Binomials, trinomials, and then polynomials with 4 terms in them. So the first thing you need is your graphic organizer. Now, I would love to shout out to All Things Algebra for this freebie that you can find on the internet. I'm going to use it to break down a very complicated topic in 2 weeks. So today we're going to look at we're going to look at the first bubble. Look for a GCF, the greatest common factor. And then we're going to look at 2 terms, which is the difference of squares. That's going to be part 1 and part 2 of this video series. Part 3 and part 4 are terms 3 and 4. Okay, so the factors. First, we're going to look at finding factors of numbers. We need this practice because we're going to need this mental flexibility coming into parts, into all the parts, because we're breaking up numbers apart. So what do I mean by find the factors of the following numbers? Well, 169 is actually 13 squared. So that's 1, 13, and 169. There's nothing else that goes into that number. The factors of 125 are a bit more extensive, but I'm going to leave you to do that. I'm going to let you practice that. I'm going to have you practice 125, 7, 100, and 216. I'm going to show you what I mean by X, Y, and Z. I'm going to break that one down for you, but I'm going to leave m squared as a practice problem for you. So when I have a number represented algebraically, I have x, I have y, and I have z. And we're multiplying them all together. So the factors of x, y, and z are going to be 1, x, y, z. We know all of those are going to be in it. But we also have xy, xz, and yz as numbers that are factors in xyz. And of course, itself, x, y, and z. Now, m squared is going to be a little easier. It's a little more straightforward of a problem. Your factors are m and 1. And m squared itself. Okay, so practice that. Go through and practice the 125 and pause the video, and then go ahead and move on. And then I'm going to show an example of what I mean by finding a greatest common factor. The easiest way to teach it is to show it. So I'm going to show you guys that. So the greatest common factor examples, we've got 30r squared 40 plus 40r squared plus 20r. The first thing I notice is that I can take a 10 out of the 30, the 40, and the 20. So I'm going to do that. 10 times. Now basically what we're doing is we're doing the reverse distributive property. Okay, we're employing the distributive property here. We're just undistributing things. So that's 3r to the 6th plus 4r squared plus 2r. So now I see that I have an r factor that I can pull out. So I got 10r times 3r to the 5th plus 4r plus 2. And then I'm done. I've found my greatest common factors. I've factored this number to the extent that it can be factored. So now let's look at negative 2x to the 4th minus 2x squared plus 12x. So that's going to, we can pull out a negative 2, a negative 2, and a negative 2. Now you're probably saying, but that's a positive number. Sure, we can pull out a negative out of a positive number. Let's try it. So let's pull out the negative 2. So negative 2 times x to the 4th. That's going to be a positive x to the 4th now. This is going to be a positive x squared. And this is going to be a negative 6x. We still have a common term of x. So I'm going to pull that out. So that's x to the 3rd plus x minus 6. Okay? And then I'm done factoring that problem. We have 2 more examples that I'm going to go through with you, and then there are examples in the homework that you're going to work on the worksheet. So we have a little bit more complicated of a problem here. So let's start by just factoring out what we see. We see 8. I'm going to pull out 8. So that's 8 times m to the 4th, n to the 3rd, minus 10, m squared, n squared. Okay. So now we got a ton of common factors in here. We got our m's. So I'm going to pull out an m squared. So 8m squared times m squared, n to the 3rd, minus 10, n squared. Now we have the n's that we got to take care of. So we've got 8m squared, n squared, thank you, times m squared, n. We have one n left over when we pull the n squared out of it, because that's, remember, n to the 3rd is n times n times n. So this could be just n squared times n. So I can factor out the n squared and leave that one n. Minus 10. And we're done. So one more example. We've got 12x squared y plus 8xy. So let's pull out the numbers that we know. We've got, whoops. Come on, erase. All right, you're not erasing, that's fine. See if I care. We got 8 and 12. Now, this one is not as simple as 8 and 80 or any of the other ones. So let's figure out what our greatest common factor is between 12 and 8. So we've got 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 8 are 1, 2, 4, and 8. Greatest common factor between these two is 4. So I'm going to pull a 4 out. 4. So that leaves me with 3x squared y plus 2xy. I'm going to look at my x's. I have one x that I can pull out, so that's 4x times 3xy plus 2y. And now I have a y I can pull out, so that's 4xy times 3x plus 2. Now, of course, I could check my work by doing the distributive property backwards in any of these examples. I'll show you with one of them, going back to the 10r times 3r to the 5th plus 4r plus 2, mostly because I have room under there to write. So I'm gonna check. I'm gonna check my work. I'm going to go 10r times 3r to the 5th. That gives me 30r to the 6th. I'm going to take 10r times 4r. That's 40r squared. And then 10r plus 2, 10r times 2, so that's 20r. And that, my friends, is the same problem. That is how you factor by greatest common factors. Stay tuned for part 2 of factoring polynomials when we talk about differences of squares.